Good morning, everyone. So to tell you the story of how I learned to write code, I'm actually going to tell you 3 stories. And the first one is, well, how did I write the first piece of code that was actually useful, that was actually doing something? Second one is how I impressed myself for the first time. I started this project, and then in the end I was like, wow, I actually did this, surprising myself along the way. And finally, how I learned some dev skills after doing this stuff before. So I thought, going over this list, that's already interesting, that like you just start with writing ugly bad code, but that's fine because, well, that's how you start. You just start somewhere. But before I go through these stories, the question is, of course, who was I before I wrote that first piece of code? And at university, I studied philosophy. And the reason I became a tester is because I was a philosopher looking for a paycheck. So it was basically by accident. It was only after about 2 years in that I realized I actually want to keep on doing this testing thing because I really enjoy it, I like it, it's interesting. So in that sense, I could stand here and claim that I'm a non-technical person. However, that's not entirely true because one of the things I did do while still at university was install Debian Linux on my machine and use it for a while. So there's always been this interest in looking into technology. I one point did a tutorial in Python and I finished the tutorial and I felt good and I was thinking, so what's next? And I had no idea what was next, and I Googled what's next, and they said, find an open source project to contribute to. And I was like, how am I supposed to do that? I've done this basic tutorial, and now you want me to contribute to this project I don't know, with all these people I don't know, and they're going to see my code. So it basically ended for me there. Python tutorial done, and then, yeah. So actually, it was quite a few years later, I think 5 years into my testing career or something, I actually got to the point where I wrote the first useful piece of code. This was for a project where I was testing a big middleware implementation. So you had all these SOAP services, you had the WSDLs, the XMLs, etc. And for part of it, we had good test automation built by the architects and a test automation engineer. And then later a third part was added on, a third set of insurance, a third insurance portfolio. And we couldn't use the automation we had, so basically what we had to do then to create our requests is to create them by hand. So you'd have one good request and you copy-pasted it to a new file and you changed some values and you had a second request to test with, and so on and so on. And that got really boring, and I was thinking, we should be able to do something here to automate this. And that's what I did. Since I had a bit of experience with Linux, and then you have the shell, and from the if you start looking, what do I do if I want to do more than possible in the shell, you get to set and awk, and then that's not enough, so then you find Perl. And you write code like this, and I really, when I look this code up again, I think, okay, so what exactly am I doing here again? Because I know this reads a file, and then this removes the line breaks at the end, and then I do some for each stuff, so I'm going to be honest here, I can't explain at this moment what this code does. All I know that what the whole script does is that it reads an XML file, which has a few keys in it. It will also read a CSV file, and the first line of that CSV file should match the keys, otherwise you'll get really weird errors, because I was concerned about that at that point. And then for every line in the CSV file, it will actually make a copy of that XML template, fill in the keys from the CSV file, and then it goes to the third line and it does the same. So basically, a simple templating engine. Ran on my machine. One reason to choose Perl is because I couldn't install anything on it because of the security policies as well, and Perl just ran without installing anything. And I shared it with some colleagues, and they were happy, and I hope they used it after I left, but even that I'm not sure of. But then I had written this thing, I was thinking, okay, so how good is this actually? Like, where do I get some feedback? So I went to the site Perl Monks, which is a community of people using Perl, and I posted this in the please review my code section. And I was quite happy with the one response I got with like, well, you've rolled your own templating system. That's the point where I realized that the thing I had written did not just work for XML files, but basically for any file. Hadn't thought about that yet. It's simple, it's a document, fair, so nothing to comment on there, except I'm confused about strict scope and then some useful links, and that makes sense that I was confused about it because I hadn't really looked into it, but this made me really happy actually. It's like, it's not a total piece of garbage. And I think the main lesson from this story that I would share with you is the best thing to do is create something that's useful to you, because as I said, I did this Python tutorial years before this, and then I was stuck after doing the tutorial. So I had this very simple thing I had to do manually, which is create all these XML requests. I thought this can be automated. I tried it, and well, luckily it worked. So it was just very simple, something for me. Some of the other testers used it, but they were sitting next to me, so we could just talk and figure things out if things went wrong. So just something for you, something simple, something small. That's the best place to start. Then, think about 1.5 years later or something. I should like cheat by looking at the years I added. I was at a different project. This was at a bank, and there was an application that kept track of risk for certain banking products. And one of the things that application did was that it would generate a general risk report and a bank risk report and a country risk report. And one of the tests that needed to be done was checking if the numbers in the general risk report matched the numbers in the bank risk report and the country risk report. And I joined the team, and then somewhere in, I don't know, in my 5th week, the tester who had been in the team for way longer said, okay, we're going to talk about how we test these reports. And she opened this testing Excel file, which had detailed instructions, and it basically said, well, you open the country risk report, and you filter this column in that way, that column in that way, that column in that way, that column in that way, and then you take some of this other column, you copy-paste the value in the testing Excel sheet, you do that about 5 to 6 times, then you go to the other report, the ones you want to check it against, you do something very similar, and then the testing Excel sheet had some formulas in it, and if that particular box with the end result of those formulas said 0, the test passed. And I listened to that, and I was just thinking, no. I saw myself doing this for a full day, just clicking around in Excel, following these instructions. And I was thinking, I'm just not going to do this. I'm going to automate this. Which was an interesting decision, or perhaps wasn't really even a really well thought through, considered decision, because, well, it's Excel, so I figured, yeah, let's do it in Visual Basic for applications, because it's Excel, so I have this whole language where I can program stuff into Excel. So I started working on it, and after a few days, project manager came to me and said, well, Joep, how's it going? And I showed him, and it did a few things. It wasn't complete yet, but I could clearly show progress, and he was like, okay, carry on. And then I think it took me about 2 weeks to get a first version properly working. Someone with proper skills probably could have done that in 1 to 2 days, but I just went at it to avoid the boring work. And the trick was basically to take very small steps. Because, of course, I had very detailed requirements. I had a very detailed plan. Okay, you open the sheet and you filter and blah, blah, blah. So I basically did the same thing, and my first victory was writing some VBA code that opened an Excel file and closed it again. And then I was like, okay, so I open an Excel file, I need to apply a filter, and then, well, the closing I already had. And I really just built it step by step, making it bigger and bigger, which helped when the project manager came and told me, so what do you have? And I said, well, this is what it does. Click a button, and it did that instead of, yeah, I have 6 components, and none of them are all really working yet, and I have some integration issues, because he probably would have said, yeah, okay, just stop, you're done here. And well, what you can see from this code is actually that my coding skills haven't improved that much. Also here, I kind of have to guess what it does, although I left some comments, which is nice. Also got very disappointed by VBA, because at some point I got these weird errors, I Googled them, and the official fix apparently was to copy all your code to a text file, delete all the code, and then copy-paste it back again. And then it worked again. So since then it has been my goal not to touch VBA again, but it worked. And also to illustrate how, well, not well thought out I was working actually was that when I left the company, I did some knowledge transfer, and this guy asked, so how did you write the code? Did you record the macros in Excel and then cleaned it up? And I was like, oh yeah, didn't think of that one. So I just literally just Googled stuff and wrote it, but well. Still it worked, and I think that's the most important lesson here, that when you're faced with such a challenge, that you just make a small change, and you test it, and you repeat it. And you have this incremental and iterative approach to it, instead of like going wide, building a bit here, building a bit there, like building a bit of opening and closing Excel files, and you need to save, and you need to filter, and you need to sum. Just build it up step by step, and you have these small chunks and these small problems you can solve. And in the end, you might actually get something that works. Well, you probably will, and you probably also have a fairly good idea if it's not working where the problem is. And that's also something I've realized, that even doing fairly small things, it makes a difference to experience on a very small scale the things that full-time developers experience all the time on a much larger scale. Having that small bit of practical experience helps to relate also to the work that the developers are doing. Then, next company, next application, integration tests, multiple applications involved. I wrote Python code using PyTest, so definitely agree with Kyle, who did the talk previously here, that Python and PyTest are awesome to work with. And well, I wrote these tests that we needed to create an app, we need to check the team server, so the SVN repository that belongs to the app, if the app was created in a project management application, and if some events were sent to our analytics application where we keep track of what our users are doing. And we also had the rule in the team that all code gets reviewed. Doesn't matter if it's test or product code, all code gets reviewed. So I had these tests, and they were working, and I was happy, and I gave them to a developer and said, can you please review those? And he looked through them, and he said, Joep, we're going to spend the afternoon refactoring these tests, because the way they are now, they make my eyes bleed. And luckily, we had a relationship in which that sort of comments worked. And I didn't have any negative feelings, because what he was basically saying was that, Joep, there is this concept of clean code that developers know, and just looking at your code, no one has ever shown or explained this to you, and I don't blame you for not knowing it, so just let's take an afternoon and go through that. And this is, well, part of the code that was the result of that. And to a large degree, I don't even have to tell you what it does, because you can read it yourself. There's test create new app, so you can all reason that that's probably a test to create a new app. I get a project ID from some helper. I check project details in Sprinter. Okay, some domain knowledge. Sprinter is the project management application. Check project in SVN properties on team server. That's probably then that SVN server. And events in platform analytics, that's where we keep track of what users are doing. And I just added this check function, which is used here, so you can see it into, see one level deeper actually in the code. And looking back at the code I wrote before we had this afternoon of refactoring, I definitely agree, yes, eyes can bleed from really poor written code. But then, yeah. So what I learned here, I thought I had this one first. Anyways, what I learned here was that, yeah, step 0 is working code. I mean, if you don't even have working code, then that's the first thing that needs to happen. But quite soon you'll figure out if you want to have maintainable and readable and shareable code, you have to start thinking about clean code. And then, okay, so what do I mean by that? Well, these are just the basics. There's a book that's titled Clean Code, and I read it, and the first part I can definitely recommend because that's mostly concepts and simple Java code. And then the second half of the book is step-by-step refactoring of this large chunk of Java code, and that's also the part where I was like, nope, my Java is not up to this. I'm lost, but that's fine. I mean, start with the basics, of course. Important basics is give things proper descriptive names. And that's also the part where you want to start using an IDE or a smart text editor at least, because the problem with long descriptive names is you don't want to type them each and every time because you'll probably make typos and then you get really weird errors when you run the code. So have a tool do that for you. Good names also means that you ideally don't have any comments. You can have comments to explain a decision you made to implement something in a particular way, but no comments to explain what the code does. That should be obvious by reading the code, and that way the code is its own documentation to a certain degree, so you're sure it will be up to date. Next one is structure. Before that refactoring afternoon, I thought the only reason to use functions and methods is to not repeat yourself. And that's wrong. An excellent reason to use functions and methods is to structure your code. As you see in this example, this is my whole test. And the only thing the test does is call on other methods and functions to do stuff on a more detailed level. And then here's another check if blah de blah, so that's even a function on an even deeper level. But by separating your code out in levels like that by using functions and methods, it becomes a lot more readable. If you want to quickly know what this test does, you just have to read through here and then say, oh, but I'm interested what this one does. Fine, then you read that one, but you don't have to read the rest of the code, which would be the case if you would. I should have counted how much lines of code this test would be in total, but it's going to be way too much to read in one go. Or on one screen, which is also a heuristic being used, like if your function of method doesn't even fit on your screen and you have to scroll to read all of it, it's too big. Yeah, finally refactoring. You're going to write working code and then you're going to refactor it, rewrite part of it, improve some names, change some structures, because it's extremely difficult to write clean code from the get-go. Start with like a blank file and just write code. And look, it's perfect from the start. That's not going to happen. So that's also something to take into account. That's going to take time. First, you build the working code, and then you spend some time cleaning it up, making it more readable, making it more maintainable. So, to summarize those 3 stories, you want to build something that's useful to you, then you'll know what it needs to do, you'll be motivated to do it because it's going to help you, and it doesn't have to be that big. You can create it in small incremental steps instead of trying to do everything at once. That's still a tendency I sometimes notice in myself, and then at some point you feel, okay, I'm losing grip here on what I'm doing because I'm trying to do everything at the same time. And then, when you've written some code, start to think about those basic clean coding principles I mentioned. And now you might think, but hang on, that last example was from 2016, so what have I been up to since then? Because I've continued coding. One of the things I did is I've built a Slack integration, and it does a bunch of very useful stuff, but as I feared, the most popular functionality of it is that you can find other colleagues to play a game of football with. So if you type /Alfred football, Alfred will actually post here in the football channel, like, Joep wants to play a game, who's in? And people can click a button to say yes. And here my colleague Ronnie said, yes, let's play a game. And once you have 4, you can go to the football table and have fun. Some challenging aspects of this was that, well, it runs in AWS, so I had to figure out how that all works. I also had, first time I encountered the concurrency problem. What happens if 2 people click the me button at the same time? I have only 3 slots available in the game, so how does that work out? So there were some new technical challenges here. But all was great fun to do. I've also published my first Python package. It was this year. It's a PyTest plugin. Again, it's not very big, but it's something that I find very useful when writing tests. This fixture will provide you with log nodes both on your session level, module level, and function level. So you can easily log stuff while in your tests, and you can either it will either show them on your display. If a test fails, you'll get the full logging, or it can just write everything to file. And we were using this, and I asked my manager, can I just open source it? And he said yes, so I was like, yay. It's like another small achievement doing this. Main challenge here was to figure out how it fits into the existing PyTest code. And looking at those 2 things I did, like potential next lessons, this is a big one because especially with how to use AWS, and then you have to package the stuff and deploy it, and then you want to write a script for that, and then you start calling APIs at AWS, so you have to start reading the AWS documentation. Similar for PyTest, you have to read PyTest documentation, try to make sense of it. So this is one of my major lessons in those 2 projects, like looking at existing code base and how to hook into that, how to use that, and also go through the reference documentation and figuring out what the best way forward was. More importantly, and this one took me a lot of effort to learn, is that I was very much stuck in the make a small change, test, repeat cycle, and testing meant running the code or running tests. And especially for the Slack integration running in AWS, that meant I made a small change, then I ran my package and deploy script, which would actually put it on AWS, and then I would test it, sending a call to the API, and then looking in Slack if it... And that took way too long. You were just like waiting until you know what the result was of the code you had written, and then often I'd made some very stupid mistakes, including forgetting a bracket, or still have some typo somewhere, or making some fairly basic mistake in how I thought the code worked, and it didn't do that. And I really had to learn to do this instead, and to learn that the test, it can be that you basically run the code in your head, instead of running the code, noticing a mistake, fixing that one particular mistake, running the code again, seeing that there's another mistake, fixing that mistake again. It got really tiresome, and I still kept doing it. So that's the main reason I'm telling you this now, that you know that there's going to be a point where you will have to start to learn this. But what I'm also seeing, I have a new tester in the team, and I'm coaching her a bit on the whole Python and our test automation. And she's still on the level like, I write a few lines of code, and I think I know what it will do, and I know what I would like it to do, but I'm not sure. And you can see it in her whole posture when she runs it. There's like this anxiety, but also enthusiasm, like, I wonder if this is going to work. And it's also funny to see myself in that. It's just like a mirror for me like 2-3 years ago. So in the start, that is what you will be doing, and that's fine, and that's great, because that's the first step. But at some point, Yeah, you need to be able to read a function or a method and think, okay, this makes sense, okay, and this returns this kind of object, and then I need to do this and that. And then you just learn to keep more and more code in your head, basically, and that will make you work faster than if you have to test everything all the time. So, what if you want to get started? So this is the part where I share some practical tips that hopefully are of use to you. Two obvious sites are Code Academy and HackerRank, where you can do introduction courses and tutorials, and I'm sure you'll be able to find plenty more, especially if you start looking for language-specific ones. I believe more and more universities are also just publishing their introduction course in Java, Python, JavaScript, whatever. So that will definitely be easy enough. A colleague of mine recently did JavaScript course on Code Academy, and she was very happy because they're able to give you really quick feedback on what you're doing. It makes it really accessible and easy to just learn basic syntax, some basic concepts, and get started. Then you can also play some games to get some feeling for it. The two on the left, Human Resource Machine and TIS 100, they're about a specific part of programming, though. They're very much about algorithms. You'll get like problems where, for instance, in this one, where you just get a series of numbers as input, and your job is to, if the first number, you need to process the numbers in pairs, and if the first one is smaller than the second one, send it to this output, otherwise send it to the other output. And the operations you can do are very much like assembly languages, so they're very low level. But it's still fun to get your head around like the algorithmic thinking that needs to happen on a lower level. And Factorio can teach you something about refactoring. The story behind the game is that you're an alien stranded on a planet, and you need to build stuff and research stuff so you can build a rocket to leave the planet. But what will happen is, you can see from the picture here that in the end you build fairly complicated stuff, but you start out with just extracting some coal and processing it, and then what happens is you build some stuff, and then you want to expand or change something, and stuff is in the wrong place, and then you have to restructure. And I found it very similar to refactoring. You have this existing code base that does certain things, you want to extend it, you want to change it, yeah, and then stuff needs to move around a bit, or you even have to do some more radical restructuring. So, these are some more lightweight ways to get a feel for it. Two books I can recommend. If you want to learn Java, there's Java for Testers by Alan Richardson. My favorite part of that book is that at the start he explains this is for testers, and as a tester you don't need to know a bunch of stuff that is usually explained at the start of a Java for Developers book or course, like how does the Java virtual machine work? How do I build a jar? He's like, you can learn that later. He gets back to that several times, like, I'm not going to explain this. Here are resources. But he really gets you started really quickly writing some basic Java and writing some tests. So you're writing code and a test for the code simultaneously, which I think is a great approach to introduce programming in any language to testers. And the book Code, it's not about programming, but it does give you a conceptual idea of what it is that a computer does at a very low level. Because he starts by just explaining you a very simple relay with a switch and an electromagnet, and then he says, well, if you take a bunch of them and set them up like this, you have your AND port, your OR port, your exclusive OR port, your NOT port, and then if you combine them in this way, you can build a calculator, and if you combine it in that way, you get a computer. And okay, it takes about 400 pages, but I thought it was a great read just to have like an introduction to that low-level part of computers. And then there's perhaps my favorite piece of advice, the big secret, that your testing skills will help you to learn to write code. And this is the first one, because yeah, this is the starting state as a tester. It's like, can you test this new feature? And then the first question, what does it do? So at that point, you have no idea what it does. And then you do a bunch of testing, and you probably still have a list of stuff, okay, I've tested, so I know all of these things, but there's still a bunch of stuff I don't know. And perhaps they're not important enough to test, and that means you'll never know. And I think that's a crucial skill in testers, and I've noticed developers sometimes struggling with being okay with not knowing stuff. It makes sense looking at the activities they do, but I'm fairly confident that as testers, okay, yeah. Or you join a new project, what do you know? Yeah, nothing, I'll just have to find out, learn, experiment, etc. And that's actually your second superpower. Because especially at start, as I said, referring to my colleague, like you write code and you have an idea of what you hope it will do, but you don't know, so you try it out and you see what happens. And you can use your testing skills to ask very good questions about what you see, what happens, because you'll see output of your code and you'll think it does one thing and then it turns out it does another. So being able to write code and then immediately test it for yourself and test it in a good way, in a critical way, is going to help you understand what the code does, and it will help you learn instead of just learning to stitch together some code you copy-pasted from wherever. And that's what I wanted to share with you today.
How do you consider yourself? Are you a tester who writes code or a developer who writes tests?
Tester who writes code, because there is so much more to being a developer than writing code, and I'm not even sure if I would dare to say that purely my strict coding skills are on the level of a junior developer. Probably not. But then there's all that other stuff that comes with being a developer and knowing stuff about logarithmic complexity and design and architecture. And on some level I have some understanding of that through testing, but basically the reason I wouldn't call myself a developer who tests is because there are more skills to being a developer than coding, and I don't have those skills, or in a too limited degree to claim that, and my background is testing, so.
Hello, thank you for the speech. Probably my question is a bit similar to the previous one. So you started your career as a manual QA, and eventually did you become a full-time automation QA engineer?
No. Yeah, career-wise, I'm a team lead, and I've done some Scrum Mastering in the past as well, so that's a factor. But I think a more important factor is that how I look at testing, I don't distinguish manual and automation in that sense. If you're a tester, you have to think about the overall test strategy, which will include different tools. So that means both doing stuff manually and doing stuff through automation. And certain people have different skill levels in different areas of testing, but the whole manual versus automation doesn't stick with me.
Hi there. Thank you for the speech. I had a question in regards to your second job, probably. When you mentioned that you did have an Excel file where some bank currency stuff was supposed to be entered, right? So how, first of all, did you do the automation in your work time? And if yes, how did you approve that to your manager? Like you've mentioned that you had several pieces of code which didn't work yet, and so on and so forth. So I suppose the manager was asking you to insert the numbers in the columns, right?
Well, I think it was a combination of getting a bit lucky with where the project was at that time, because I joined the team at a time where there was little activity, and the idea was to get me up to speed so that when the next release would be delivered by the third-party developer, we had 2 testers who could test at full capacity and that I was up to speed at that point. So that also gave the project manager some leeway in saying, sure, you go ahead, because I did do it in my working hours. And I'm not sure what would have happened if he said that I couldn't do it, because I would have, I was not going to do it by hand. So yeah, I have no idea what would have happened, but I just was very firm and I said, I'm going to do this. And yeah, luckily I had something to show after 3 days when he checked in with me. So in that sense, well, I could refer to the Grace Hopper quote that it's better to ask for forgiveness than afterwards than for permission beforehand, but yeah, that's not always true either.
Lucky you.
More questions? No? Okay, then I ask myself, so do you have any experience with merging your tests into continuous integration delivery pipeline?
Yeah, we have a pipeline running which contains some of my tests. But I got lucky that, in the sense that one of our developers built it. And I have made some changes to it, but he did the most difficult part of getting it all set up, making sure that an environment is spun up and that the tests run against it. So in that sense, all I have to do, or the most important bit is just adding 2 lines to one file in a repository, and then it will also run the repository that it refers to. So I'm not sure, are you looking for certain experience?
Yeah,
or,
this actually was the topic, that if you write the tests, do they execute somehow automatically after developers push code to Git, for example?
Yeah, they do.
So, thank you. 5th question.
Hey, my question is going to be a very pragmatic one. I mean, when you are day-to-day in a fast-moving project, when your plate is full of manual tasks, how do you convince your manager or the client to make yourself work in automation, where the clients are not sure that your automation is going to be fruitful to them?
I think I would say that they don't get to decide. And that probably says a lot about the current environment I'm working in and the amount of responsibility and authority that our teams have. But we have had user stories, and then, okay, but we need to build some automation to go with this, and that's going to take extra time. And that's not up for discussion. And yeah, I would say that it's not a manager's or client's job to, because what they're basically doing then is telling you how to do your job. Then they might as well start telling your developers how to implement certain things, of certain choices to make. So realizing I'm saying this from a very comfortable position, seeing as the company and my current job, just the only way to do this work properly is by spending some time on automation. So, dear manager, dear client, if you want this, then you'll have to accept that. Because, it really feels to me that at that point the client and the manager are trying to interfere on a too detailed level of what a team is doing. But, well, we can talk more afterwards, because, I mean, perhaps then if I learn a bit more about your specific situation, there's some more helpful things I can say than just ignore what they're saying and go for it.
Thank you.